and so I'm going to be shortening your homework assignment. So in case we run out of time, I actually want to first off tell you the parts of the homework assignment that you need to do. So here we go. Get out your little homework that you picked up, and I want to tell you the problems that you do on your homework. You need to do 7A and B, so you'll want to circle the ones that you do. 7A and B. 8A. Okay, and you can turn the page. You're going to do 12A, B, and C. You're going to do 13A, C, and D. And then on the back is 17B and D. So the reason that I'm limiting it to just these assignments is because that's the portion of the concept we're going to learn today. We'll add the rest of it tomorrow, so you'll end up doing those tomorrow. Okay. You do not know how to do the bonus yet. Okay? All right. So, on your notes, we start here. What are the characteristics of a binomial trial? So actually I want to begin by saying chapters 14 through 17 are about probability. And, I always want to tell you why we're doing what we're doing. Okay, so this whole unit gives us an idea of what should be happening. In theory, if everything does what it's supposed to do, then this is about what you should get when you take a sample. Okay? So if I know what I should get when I take a sample because of what I'm learning in this chapter, then you go take a sample. If that sample you take jives, then okay, good. But if it's crazy weird and really far off from what you say should happen, then something's wrong. You could have a bad sample. That actually probably happens less than, and when we go with that, what should happen is actually probably something else. All right, so that's what we do next semester, but that's where we're headed. So, the main goal of today is to understand the difference between binomial and geometric. And first, we need to know that you have some characteristics. This word, Bernoulli trial, has some characteristics that are not a key vocabulary word that you need to know. Like binomial is important key vocabulary, and geometric. Bernoulli isn't really, it's just that's what it's called. And here are the things that we are dealing with. We will be dealing with events that have a success or a failure. That's your only two choices. You stop at the red light or you do not stop at the red light. You catch a cold or you do not catch a cold. Okay, you do that or you don't do that. It's not another option. Okay? The second characteristic is that you have independent events. And so, for example, you would have independent events if the fact that you got stopped at the red light Monday is not going to change whether you get stopped at the red light Tuesday. And that won't change you getting stopped at the red light Wednesday. Okay? So one event happening does not change the probability of the next event occurring. That's independent. Okay? And third little information kind of falls from that, and that would be then all of the events have the same probability. For example, getting stopped at a red light on Monday is the same probability as on Tuesday and Wednesday and Thursday and Friday. Now, we were talking maybe getting stopped by the train going through town. Maybe the probability is stronger on Monday because they have more weekend shipments that they're taking care of or something. So if the probability on Monday is different from the other days of the week, then this is not what we're talking about. Okay, then this would not be these kinds of problems. All right, so here's what we're dealing with. So let's talk about this idea of binomial versus geometric. So here we go. A binomial event today is going to be when you have exactly, and I'm going to use a letter, K successes. So I want to know what's the probability of you getting stopped at a red light exactly 2 out of the 5 days that you're driving to school. Okay, exactly K successes out of N trials. Okay, and each day driving to school would be a trial. So that's the kind of thing we're looking at. Now, still here, now think about this. If I say you're getting stopped exactly 2 times out of the 5, am I defining for you? Am I telling you where exactly those 2 occur, or can they be anywhere? Sprinkled anywhere in the week? What? They can be sprinkled anywhere. So we can have any combination. You have to account for them all. Okay, any combination of events. They could be on Monday and Tuesday, Monday and Wednesday, Monday and Thursday, whatever. So those 2 can be sprinkled anywhere. All right. Now, geometric events are when you have a situation that you will go until, that's kind of the key concept, until you get 1 success. So what's the probability that you will not get stopped by the red light until Thursday? Because what happens? If I say that you don't get stopped by the red light until Thursday, then what have I essentially told you about Monday, Tuesday, and Wednesday? What have I done? Yeah, I have defined for you the specific order of events. So see, that's what's different about the geometric, is that I know the order, okay? I know the order of events. Okay, so before we go on, let's kind of talk about a quick little memory way you figure these out. These are just my silly ways. When I was in college or whenever you had to remember stuff, I always look for a way to remember it. I don't know what this is. I'm getting email or something. Okay, so here we go. How about this? Any combination is binomial. So you got A, B, C. Any combination, A, C, B, is binomial. Any combination is a binomial. And then I've got a couple of ways here. In the alphabet, we're talking ABCs. K, you know the order is a lot closer to G. G, H, I, J, K. Than B is. I also have been told, if you know, use geo. Use geo. So if you know the order, use geometric. Okay. So whatever helps you. If you don't like either one of those ways, whatever. I'm just throwing out some options if that helps you remember those vocabulary words. Okay. So let's actually do a problem. Here is your homework problems that you're doing. Here is your number 3 on your notes. We're going to do this problem, and I'm going to give you one of the ways to do it is geometric, and one of the ways is binomial. We're going to talk about the difference between those. So here we go. Number 3. 25% of customers entering a grocery store between 5 p.m. and 7 p.m. use an express checkout. Okay, so let's think about that. Customers going to Brookshire's between 5 and 7 p.m. or what kind of customers? During the work week anyway. Coming home from work, grabbing a couple quick things that they forgot for dinner or a couple things to get for dinner. Okay, so according to this, the claim is that 25% of the customers entering are going to use the express checkout. Okay, So we're going to consider 5 randomly selected customers, and we're going to let X be the number among the 5 who use the express checkout. So we're interested in how many use the express checkout. So let's first define some variables. You've got some space there. Let's let P be the probability. And you actually do have to write down what you want P to represent, because it could be something else. So in this case, we're probably going to have P be the probability of the customer use the express checkout. Okay? And that number is 0.25. Okay. Now, we're going to be considering 5 randomly chosen customers. So that would be our N value. That's our number of trials I'm asking you, I'm asking these 5 different. So 5 is that. And then if we want to talk about how many successes, that's going to come later. All right. By the way, this is what we would be challenging next semester. You tell me 25% use this. Okay, well let me go take a sample. If my sample is way different than this number, then I'm gonna say you're wrong. This should be something else. You could say it should be lower, it should be higher. I can't tell you what it should be, but I would challenge that, and that number should be something else. Okay, so that's next semester. That's where we're headed. Okay, so here we go. I want you to decide, is this geometric or binomial? Find the probability that the express checkout is not used until the 4th customer. So what's that? Good. Geometric. And so on your homework, you're going to be putting a big G or a big B beside the problem, because that's the first critical decision you make. Is it geometric or is it binomial? That's what you have to figure out first. So because they tell me this, it's not used until the 4th customer, then I know that this person uses the express checkout. So therefore, these people what? Do not. So I know the exact order. So let me put some probabilities to this. Oh, I wanted to put this actually here where I have more room. Okay, sorry. So it's not uses. Not doing express checkout is what probability? 0.75, okay? So here's what I got. And I'm going to show you a couple of ways that you can compute this, okay, in your calculator. First off, you can just straight up do it the way that you've always known you could, by 0.75 to the 3rd power times 0.25. Okay? So there's a 10.5% chance that any 5 random people, of those 5 random, I won't get a person using the express checkout until the 4th person I choose. Hey, what's happening on this 5th person, by the way? Yeah, who cares? I don't care. Anything. That person's just, 100% of things are happening to that person, so whatever. Here is another way that you could do this. If it gets a little more difficult, then using the calculator function is helpful. And so here's what that is. I'm going to show you how to find in your calculator geometric Pdf, because you're going to have a particular placement that you want that 4th or that customer to not use to use the checkout. A particular place. The particular place I want is the 4th place. So you need to put the probability and then that, the place of the success. So in this case, you're going to go geometric PDF, and the numbers you would put in here are 0.25, and I want that to occur in the 4th spot. So here's where that's located. It is in 2nd vars, and then it's a long list I would actually go up to the bottom of the list. Instead of going all the way down to the very, very, very bottom, if you press up, you actually get to the bottom of the list and work your way up. And look there, there's geometric PDF and geometric CDF. C stands for cumulative, and I'm teaching you that tomorrow. We are just talking about PDF. That's exactly in that fourth spot. So we want to go geometric PDF. And I want the 25% chance of being in the express lane to occur at the fourth spot. And I hit enter, and there it is. Okay, either one of those ways, good to go. You can do that. All right, so the geometric, we've kind of done that before. Let's do the binomial problem. Here we go. That's this one, the second one. Find the probability that exactly 2. So I just want 2 of those successes out of the 5. And they can be sprinkled anywhere. So there can be any combination of 2 sprinkled amongst those 5. So that is what makes this what type of problem? Binomial, because it's any combination. They can be sprinkled anywhere. Okay. So let's actually talk about how to do that problem. So you have this in your notes. This is the next thing you have down there under number 3. It says, for the binomial distributions, we have to consider that there are all the combinations. There are options. Now this says, in other words, the order matters. I actually want to change this. Instead of saying the order matters, I want to say the order is unknown. Okay? So you have to account for any combination. Okay, we have to count for how many those things are. Now, I'm going to show you how to compute this in your calculator real quickly, and then we are going to break it down. Okay, it's important that you understand where everything comes from, but let's just kind of plop out how you get there and then break it up. Like the geometric PDF, we are going to be doing binomial PDF. Again, particular, I want exactly 2. Particularly 2. Not up to 2, or at least 2, and that would be like different sets of things. And we will put these in order in this parentheses, N, comma, P, comma, K. And so I'm going to have you remember NPK by something real silly. By, let's see, narcoleptic prancing kittens. Okay? Silly phrase to remember, NPK. So I want you to think about, well, what's narcolepsy? You know? Yeah, you fall asleep for kind of no reason at all. You just kind of like totally flat out in the middle of a sentence and just go to sleep. Sometimes, but you know, you couldn't drive. You have a lot of things that you could not because you could be in the middle of driving on the highway and then boom. Okay, so imagine some little prancing kittens flopping around, dancing around, and then boom, they fall over and are asleep. Okay, you might also, I actually have a video to show you on that. Here, let's do that real fast. Okay, so narcoleptic prancing kittens. That's how you guys are going to remember NPK. So back to this. We're talking about this problem. Our little grocery store. We got 5 people. We want to see the probability of exactly 2 of them. So we're going to go put into our calculator binomial PDF out of the 5 customers that I choose randomly with a 25% chance of them using the express. I want exactly 2 of them. And then we can plop out an answer. So here we go. Let's show you where that is. Same place as before, second vars. So go second vars. And instead of going all the way down, it's probably quicker to go up from the bottom of the list. And it's binomial PDF, not CDF. That'll be cumulative. We'll do that tomorrow. And I want N, P, K. And so that means if I select 5 random customers from between 5 and 7 p.m., there is a 26% chance that I will have gotten exactly 2 of them that went through the express checkout. Okay, so we came up with 26% chance. All right, so that's where we're headed, but I have to break down exactly what makes that different from geometric. And so this is kind of like a process that I have to take you through and show you, because you need to understand where this comes from. All right, first, when I said I want 2 out of those 5, am I defining where those 2 are, or can they be sprinkled anywhere? Okay, they can be sprinkled anywhere. So I want to demonstrate all the combinations that could occur. So let's do that. If X is my customer that used the express lane, then I could, out of 5, then that could have occurred on the first and second person I asked. It could have occurred on the first and third person I asked. It could have occurred on the first and fourth person I asked, or it could have occurred on the first and 5th person. Okay, now, where would I probably go next if I was doing these different combinations? Second and third, and then second and fourth, and then second and 5th. So I'm now up to third and fourth, and then you actually have run out of room on the bottom of your page, so you might have to just kind of throw that down there. Third and 5th, and the last one is 4th and 5th. So how many different ways can 2 express customers be sprinkled amongst my 5 that I asked? 10. Good. So there are 10 combinations. Okay? So that's the important thing to notice. So what happens is, any one of these has 2 successes and 3 failures. So that would look like this. 2 are at a 25% chance, and 3 are at the 75% chance, right? Is that 2 successes and 3 failures? Because every single one of these lines has 2 successes and 3 failures, okay? And how many combinations are there? How many lines do I have? 10 of those. So if I multiply all of that out on my calculator, here's what I get. 10 times 2 successes times 3 failures. Boom. You see, it's the same thing that the calculator got when it did the binomial function. So what it's doing is not just doing one of these pictures, it's doing all 10 combinations. Alright, so what's the hard thing about this formula to come up with? What's the hardest part of this formula to come up with? What value in here? How many combinations? Very good. This is the trick. This is the thing that is difficult. Okay? So I'm going to show you that you should not have to just do all of this stuff right here. No. That's not efficient. We've got a formula figured out, so let's do the formula. So I'm going to tell you the formula so you could easily get the number of combinations. Okay, so turn the page to the rest of your notes, or turn the page to your notes. This actually is going to be located at you're going to have to write at the very tippy top above the words. It says, this actually comes from in combinations of k items. So that, in our case, that would be, we want to have, in our case, 5 with combinations out of 5 combinations of 2. That's what we're dealing with our little store problem. Okay? So this is the formula. And so, I want to, statistics is a language, so I'm teaching you how to say and how to read the formula. It's not difficult. I'm just teaching you how to use it and what it says. So, what this says is, let's do this with our problem, our 5 choose 2. We want N out of N, 5 customers. I want exactly 2 of them. So you would say this, 5 choose 2. This is not a fraction, 5 halves. There is no fraction line there. So don't write that as a fraction. This is 5 choose 2. And this represents a number for how many combinations there is. Okay? And here's how you figure out what that number is. Do this. N factorial, that exclamation point is called factorial. And in other states, they've actually done this, but in our state, we don't learn factorial really until this class. So we've got 5 factorial because it's N factorial. And then look at the bottom. K factorial means 2 factorial. So that's your successes, and N minus K is your failures. So if 2 go through the checkout, express checkout, how many do not? How many? 3. Okay, so this will always be, these 2 numbers down here are going to be just added to the top number. So let me teach, anybody know what mathematically that little factorial symbol does? It's real simple. It's just a countdown, and you multiply all those factors. So you go 5 times 4 times 3 times 2 times 1 on top of 2 times 1 times 3 times 2 times 1. And then you get your number. Well, guess what? Since these are all multiplying and they're factors, we can cancel the things on top with the things on bottom. So I'm going to cancel out 3, 2, and 1. And I am left with 20 divided by 2, which is dun, 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 10 combinations. So that's how you can figure out how many combinations there are without drawing them all out. So I want you to practice one real quickly. I want you to ask 10 people at the grocery store and see what's the probability that exactly 2 of those 10 people at the grocery store. So how many combinations of 2 in groups of 10? Okay, so do that. Okay, notice I kind of took a little shortcut in how I wrote this, and I did not write it all out down to the bitter end. I stopped at 8 factorial because I knew all of that 8 factorial is going to cancel with the 8 factorial on the bottom. Okay? So I have 90 divided by 2, which is how many combinations? 45. Man, I'm glad that I did not have to write all of that out. Okay? So, if I was to find this probability, you would then need to use this formula. So you now have this at the top of that sheet. This is the critical formula that is the way that you show work. The calculator plops out an answer. I already showed you how to do that with Binomial Pdf. So the way you get credit is by showing your work, by writing out this formula with the numbers in it, and then you can just plop out the answer. So let's do that for our problem. So here we go. So the probability of, so we were wanting to have exactly 2 go through the express lane. So that's the problem. Find the probability of x being 2. And so that equals, okay, according to this formula, what should I write here? So I need to note the combinations. For our grocery store problem, what I'm going to do, 5, choose 2. Okay. Alright, now let's look at this. T to the K. This is the number of the probability of success and how many successes. So how many do I want to go through the express checkout? How many? Okay, so then put 0.25, and I want 2 of those. Alright, this part is all the failures. Probability of failure. So what's not going through the checkout? 0.75, and how many of those would I have? 3. Okay? Boom. That is showing your work, and then you hit, then you go do this in your calculator right up there at the top, Binomial Pdf 5, 0.25, 2, and you get 26.3 whatever percent. Okay, so you do that. Alright, so that's all the learning for today, but we're going to practice 3 more little problems. So there is some things, for example, your number 4 in your notes is about cumulative. So see, going at least, that's cumulative. We learn that tomorrow. So let's skip number 4 and 5 and go to number 6 on your notes. So here we go. Number 6. All right. Suppose 75% of all drivers always wear their seatbelts. Let's investigate how many of those drivers might be belted among 5 cars waiting at a traffic light. Okay. So I would want to go into a problem first thinking of my variables like N and P and K. So N, what I'd be talking about here? Among the 5 cars. So that's how many? So that's my 5. Now, what's this 75% represent? Okay, so I need to define that. It's important. This is not extraneous. Probability of wearing seatbelt. And the reason it's not extraneous is because down in the lower problem, problem E, it's going to be talking about the probability of not wearing your seatbelt. And so it's important that you define this. And that equals 0.75. Okay, so here we go. Let's answer the question. When I read this question, the first thing you should be thinking is you should be filtering and deciding if it's geometric or binomial situation. Okay, so here we go. Find the probability that the first driver not wearing a seatbelt is the 5th car that arrived at the light. So do you know the order, or can any combination work? You know. So if you know, then it is geometric. If you know, it's geo. I like to draw it out just to kind of show. So we're going to the 5th. This 5th one is the first driver not wearing a seatbelt. So what's the probability? What is this one? Not wearing a seatbelt, that's how much? Huh? Is that the 0.25? Okay. So all of these here are the 0.75s. How would that look in my calculator? I'm going to show you 2 ways. What's one of them? .75 to the 4th times 0.25. Boom. So that's the way this has to happen. It's 8% chance that wearing it, not wearing it. Anytime I go out there to the light. Okay, but I could also go second bars up to geometric PDF. And I want the 0.25 to occur at the 5th spot. Okay, do you see that? I want the 0.25 to occur at the 5th spot. So that's, again, your 7.91%. Okay. Good. Next. B. Find the probability that the first driver wearing a seatbelt is the 4th car. So is this geometric or binomial? It's geometric because I know the order. Geometric knows the order because I'm saying the first car. So I'm telling you what's happening at the 4th. The first 4th is the what? The first one wearing it. So what percent goes here? Okay, so this is your 0.75, which means all of these were your 0.25s. Hey, what about this 5th person? Yeah, who cares? Okay, so here's you putting this in your calculator. Here's your two ways. Your 0.25 to the, oops, that's missing a point. Okay, so your 0.25 to the third times your 0.75. And then how would I do that with my second bar's geometric PDF? What would I type in there? Yeah, I want the 0.75 to occur on the fourth spot. Okay. All right. We are going to skip questions C and D because those are about cumulative events, and that's for tomorrow. And so E, here we go. E says this: find the probability that there are exactly 3 drivers without a seatbelt within the first 10 cars you examine. So what's that? That's binomial because the 3 can be sprinkled any combination throughout there. Now, N in this case is how much? 10. K, how many successes do you want? Huh? How many? Okay, if you want 3 successes, then this P has to be the probability of not having a seatbelt. Not this. It's not this. That's wearing a seatbelt. So that means on this problem, you're setting P equal to what? 0.25, because P is the ones without a seatbelt in this problem. So you need to let's write out the formula. Here's the work. Probability that X equals exactly 3. The formula, N over K. N choose K, so that's going to be 10 choose 3. I want 3 successes. What's the probability of success? 0.25, and I want 3 of them to be 0.25. And I want 7 of them to be 0.75. So I'm going to go and put that into my calculator, because I do not want to have to calculate all those combinations. I'm going to go Binomial Pdf, and I'm going to put in NPK. And I get narcoleptic prancing kittens, NPK. Okay, now, if you have 3 of them without a seatbelt, how else could you have done this problem? If you have 3 without, then how many have a seatbelt? So if you call X being with a seatbelt, and that means 7, watch this. 10 choose 7, and this means I want 7 of them with a seatbelt, 3 of them without. Guess what? Let's do it. These should be the same thing, because they mean the same thing, right? 3 without means 7 with. So, 10, comma, 0.75, and I want 7 of those to have their seatbelt. Boom. Same answer. So you have to make sure that this number coincides with your success probability. And then you'll be fine. So it's 25% chance. Okay. So again, if you did not catch those, here's the ones you do. And we will learn about all the cumulative stuff tomorrow. Goodbye. Okay.